Okay, hi everybody. I'm Alice. I started Makielab, let's see, what month is it, April? 2 years ago, exactly, officially, but it took me a couple of months to get founders started and then another couple of months to get any money for this idea. So we're about a year and a half old, and we launched our first toy, Makies, last May. And we've been in what we call open alpha ever since. We are a toys and games company. When I got started, people said, well, toys or games, which one is it? Our toys are built from games technology. They're all born digital. And we blend both. The reason we can do this and the reason we do this, and I said we are both, we're sticking with both, is because various technologies, as you know, have turned up recently which allow us to do this. 5 years ago, we would have not been able to do this. So this is we think, the world's first, no, we're sure, the world's first toy with a capital T. The only thing that differentiates our toys from one of the many 3D objects that you've seen kicking around is safety certification for children and for play. And this is important for a toys and games company. This is how it got started. I was given these two books in around 2007-8. The Real Toy Story, which I recommend if you're interested in toys and what happened to the British, American, and German toy industries in the past 3 decades. And Makers, a book by Cory Doctorow, happens to be my husband, said, here, read this. But also Makers, in 2006-07, he was writing it, and it kind of covers what we were looking at the time. And we were hanging around in fab labs, and I started to see these 3D printers and things kicking around. One of the first things that happened when Cory wrote his book and published it was a couple of months later in the mail, this turned up, and this was a 3D printed physical version of his cover, one of those kind of Airfix pop-out toy things, and I immediately wanted to break it and try and assemble the pieces, but I was told to leave it alone. At this time, I was playing a lot of World of Warcraft, still do occasionally. I'm a big, big gamer. And World of Warcraft, I spent months in it, months and months, with friends, playing. That's me right at the front. And this character meant a lot to me. After spending literal months, you kind of want something to show for it. At the time, well, actually a little later, kind of I think around 2008 or 9, a company called Fingerprint started, and they were offering 3D printed Warcraft characters. And they were being sold as statuettes, as a kind of souvenir. $150, you get a little 3D printed figure of your particular character in a bell jar. So it's perfect for sticking on a shelf and going, that was me for like 3 years. I lived in that thing. Warcraft was one of the first examples. I mean, this has been going on for a while, of games as a service. Massively multiplayer games, always on. They carry on without you. You turn up. You play when you want. You play how you want. You can buy virtual goods in them. And it goes on. Everything is customized to you. You have an individual character. You hang out. You do stuff. That's a busy night in Orgrimmar, I think, Azeroth, somewhere in Azeroth on a Saturday night. The other thing that started to happen, as I said, the stuff that we were seeing in Fab Labs and that has been mentioned a couple of times today already, is the beginning of this putting this technology in the hands of people. So there are services out there that allow you and me and everybody to get your hands on this. You don't have to go to a Fab Lab. You can just sit at home and do it. You can do it on your computer. You can upload a thing to a third-party service like Pinocchio and have it made. So Pinocchio offers 3D printing. You'll see these little laser cut boxes quite a lot, and a lot of laser cut stuff. Shapeways is probably the most famous space where you can, the corner shop, if you like, on the internet, where you can upload your shape and have it printed in multiple materials. Manufacturing as a service, that's what this is. This is offering manufacturing as something that you can do that is personalized in many, many cases, which is completely unlike traditional manufacturing, and that offers the sale of physical goods. Makielab is a company selling 3D printed objects to people. We do digital goods and physical goods. I heard the term the other day, phygital. Don't like it at all. But we're doing literally both. We raised VC. That's how we got started. So we raised funding from Europe, mainly, a little bit in America. from Scandinavian countries, and we got started as a traditional startup. So what we do takes slightly longer than digital startup stuff, because physical is hard. It's difficult, it's messy, it's dirty. That said, we can do it. This is what you normally see in a toy shop. So I'll give you a really brief history of toys and why you don't normally see toy startups, because it's incredibly expensive to get started up as a toy company. I actually had the idea for this at the toy fair in 2010. I was at a digital thing, being a digital person, and it was co-located with the New York Toy Fair for the first time ever, and they have a very small lunch place, so everyone's like this when you're having lunch. And I eavesdropped a conversation next to me of somebody pitching Toys R Us, and it was fascinating. What happens, and this shows up in the research, what happens if you want to make a toy is you have to pay for the idea, you take it to China. In the case of a doll, you pay for tooling of parts. So in this case, each little piece here is a separate mold, costing, really, if you want industrial stuff, £10,000 per mold. We could get a full doll molded in China for maybe $35,000 quoted, so probably $50,000 once you got it right, and then more if you include your team time and going back and forth to China. So you got your molds made, and then you need a minimum run of toys manufactured, let's say 5,000. They'll charge you maybe £3–4 per doll, and you'll want to get it over to a retailer. This is what I eavesdropped at the toy fair. The retailer wants those products in the warehouse in America before they'll give you any money, before they'll tell you, yes, we'll take your product. So this poor man pitching was like, well, what do you mean? I can't afford to have 5,000 of these books with little toys attached made and then shipped to America and then warehoused before you'll even say yes. And the person from Toys R Us just said, sorry, that's how it works. So if you want to get a doll or a toy made, I mean, plushies are cheaper, but it's a big upfront cost, and then you have to do the marketing. Toys land on a shelf. The reason Barbie is that high is because that's the distance between two shelves in 1950s. That's what happens. They are created for the retail experience. As it turns out, this is one of the toy floors. The big main toy floor in Hamleys, for instance, I thought Hamleys went around and chose what went on the shelves, but that's not the case. In fact, manufacturers go and buy shelf space. So if you want to go up against Barbie, you have to buy that shelf space. Again, not something a startup can really do. The toys themselves are not individual. They're all the same. Obviously, a child is an amazing computer machine and will apply fantastic imagination and story to toy playing and learning, but the toy that they get is exactly the same as everybody else's. That's because manufacturing works that way. Once you've made a mold, you're not going to make it for one person. You're going to make it for 1 million people, so everybody gets the same thing. If you want to try and customize a toy, you have to do it the hard way. You have to make multiple molds. American Girl is the expensive doll in America, I think mainly sold to Republicans. Starts at $109. And apparently the average spend in a basket is $400. American Girl is in America only, but it's on Fifth Avenue, and it's in the Grove in Los Angeles. And you see people going in, and they go in with little 8-year-olds, and they come out with huge bags. And the way that works is they have 40 dolls that all sort of look the same, but are slightly different. So if you want one with brown eyes and curly hair, you go in, and there's the 40, and you discount the blonde ones, and et cetera, and you get it down to 3, and then you choose from that. Then this happens. So the second book called Makies turns up. Chris Anderson, who I'm sure you all know is the ex-editor of Wired and now Mr. Drones, he wrote this book. And the biggest question I've been asked recently is, so this is the new industrial revolution. It's amazing. So we can just shut down China and bring everything back, right? No, China's going to carry on. But what this does is it opens up. It's a massive opportunity for new types of product. So singularly customized dolls, for instance, or toys. It also opens up opportunity for normal people to have a go, who don't have $250,000 to do a prototype and then already a deal with Toys R Us. 3D printing is at the peak of the hype cycle, the Gartner hype cycle. It's published every year by Gartner Research, and it tracks technologies, et cetera, as they go through the cycle of emerging, massive hype, massive trough, as people go, well, what do you mean I can't print my own kidneys at home on my MakerBot? and then general acceptance into the mainstream. But with 3D printing in particular, there is a good reason that it should be at the top. And in fact, the trough won't be very big, because there's a number of things that's happening behind it that's incredibly exciting. It started, well, it started 20 years ago in Germany and America. But this little revolution that we're all seeing started very recently, a couple of years ago, maybe 6 now. This is Professor Boyer from the University of Bath, who created the RepRap, the self-replicating 3D printer. And I think it's like $300 now. And you can see he literally did it in his kitchen. I love that. This is what you're more likely to see. A MakerBot, say, probably the most famous of all of the cheap desktop 3D printers that are going around. We have 3 of these that we use to prototype things like shoes with. And an industrial machine. You see less of these. Most people are like, oh, so you print the dolls on a MakerBot? The answer is no, for many reasons, but mainly that we print with powder for a very fine surface. And these are industrial-sized machines. So in a small one, they can turn over about 36 of something that size in one print, and on the big ones, it's more like 250. You'll see things like laser cutters. These are the ladies at Tatty Divine who do laser cut acrylic jewelry. This is the other thing that's been happening in the past couple of years. Tatty Divine have the laser cutter right there in their shop. So you walk into the shop and they do beautiful jewelry, but there's the little counter and there's the laser cutter. And you go in and you say, I want my name with a little star off it. And they go, sure. And over they go and they stick it on the computer and they cut it out and they hand it to you. This, again, manufacturing as a service, is revolutionary. Arduino, I'm not going to talk about this much, but again, you'll notice the laser cut box. That's a little Arduino computer right there. Arduino is the $40 board, and you can do all sorts of stuff with it. I just saw the other day that there is an Arduino-powered CNC mill on Instructables. This is knowledge that's being shared and cheap enough for anybody in this room to have a go. And you put this in the hands of people, and they are going to make stuff. I'm seeing 5 forces at work here. Moore's law, everything is getting cheaper and it's getting faster. Every year, MakerBot's machines get bigger, cheaper, and faster. The resolution gets better, and there's not just MakerBot. There's something like 500 of those FDM machines now. I think the cheapest is at the $300 mark. Next year, it'll be 100. The year after that, it'll be 75, and on we go. It's rapid. Open source started with RepRap. RepRap is open source. Professor Boyer put the plans on the internet. Brie Pettis picked them up. At least I think he did. I think this is how it happened. It was around the same time, and said, I'm going to stop being a primary school teacher and I'm going to go and make 3D printers. That kind of knowledge sharing, everything that we did to get started, because we're first at what we're doing, there's nobody we can just copy. We had to learn the hard way. So we had to have that knowledge shared, and luckily for us, it is shared. Open source, where was I? Moore's law, open source, diversity. I've got these ladies up here, because the diversity in this I find fascinating. These are the 3 ladies up here, top left, are the ladies behind the Bear Paint Collective. That's Limor Fried in the middle at Wired, who is running Adafruit Industries, where you'd get a lot of your Arduino stuff. That's Jane, who makes Sugru, the incredible rubber. This is a little lady on the left here. What's her name? Valentina. And that's from Made Safe, M-A-I-D. And again, this is bringing this maker stuff into the hands of kids in Africa, worldwide, who can just have a go. And obviously, Alex Deschamps-Sonsino, who's talking this afternoon, who made the Goodnight lamp. Where was I? Diversity. So Moore's law. I'm sorry, I'm running through this. I should have notes, but I don't. Moore's law, open source, diversity, knowledge sharing, and the last one is, I forget it, but let's say it's the ability. So what happened here, this is how it gets started. I'm just going to run through very quickly about how we did it, because it's very dirty and it's very hands-on. It's very messy, but it happens. So it started with a picture. I went to Shapeways and I found a modeler, and he modeled a naked, big-headed lady, and we printed it. It was 220 euros. It was that big. It wasn't good enough. It was floppy. We iterated it. It went smaller. It started to have joints. They fused. We realized we had to not do them in one piece, and we had to do it in little pieces and assemble it. Started to do that to pose. Oops. and really pose, which, by the way, Barbie can't. Somebody pointed out to me that the only difference between Barbie, a fashion doll, and Action Man, an action figure, is that Action Man has knees and elbows. He can ride a motorbike. Barbie can't. She does that. So we set out to build dolls that can ride motorbikes, because I have a 5-year-old daughter, and God damn it, she's going to want to ride a motorbike, I'm sure. This was important to us. And then open alpha. So we realized that we were at the point where we could, with the first bit of funding, we could keep all of this stuff in stealth, or we could join in with that knowledge sharing, talking to customers and figure out what they want. So we went live, even though the dolls were bone white only at that point. They were £100. They weren't toy safety certified when we were launching in May, but we put it out there anyway and said, what do you think? You know, what should we change? What should we do? People started making their own dolls and printing them out, and we got that bit right, which was good. They went off to the right people. That's what it looks like, by the way, if there's any, it's dirty. This is what it had to end up as. So from that kind of very messy thing, there's polishing, there's cleaning, there's dyeing now, there's the application of hair, eyes, clothes. It goes in a box with a certificate and a number, goes to the right customer, all the right parts, having the right parts go to the right person when each part is individualized is a big deal. We have a workshop in London. At the moment, we are manufacturing in Amsterdam and London and assembling right in the middle of Shoreditch. That will change over time. But one of the other fascinating things about this is we can manufacture these toys anywhere that we see those similar industrial-sized machines. So in order to go international, to have toys made in America and made in Britain and made in Japan, we need to put an assembly person and maybe a biz dev person near that printer, and that's it. That's the distributed manufacturing network, kind of like the internet. No more centralized factories. Our users started to come back to us and said, this is what we want. This is one of our customers. She has bought 2 dolls. She dressed them up for Movember. She did a little charity thing for her dolls. One of the chaps said, I want Lego backplate so I can stick Lego because I've stuck Lego onto mine with Sugru, and this is what I want to see. So now we've got a Lego backplate, so you can just do that. Sue, one of our users, said, this is what happens when you paint the face. We don't do face painting at the moment. It's one of the hardest things in toys, is painting. And it's why it happens in China, because they're literally still hand-painted by people who are paid next to nothing. Skylanders, the most popular toy out there at the moment, hand-painted in China. Really hard. At the moment, we don't paint anything. They go out as they are, and we encourage people to paint their own. But obviously, not everybody can paint their own, so we're looking into that at the moment. Skin color, we started doing experiments, with onions. The top ones are boiled in onions. The bottom ones are boiled in PG Tips, a popular tea brand in Britain. We boiled them in blueberries, raspberries, willow, all sorts of stuff, saffron, just to see what would happen, because it's slightly porous. It soaks this stuff up. This is one of our users who is doing some sci-fi stuff, and so this is one of his dolls, and he sent his back that he'd dyed with tea and showed us how to do flocking on the head, which is amazing. So we've cracked skin color now. We do it with dyes, with just Dylon Industrial, as it turns out, and that's what they look like now with color applied. Next challenge for us is how to figure out how to do face-ups or automated face painting in some way. So this, I'll just wrap up now. This is what we've got. We're almost a year later. We're not quite in beta. We just put an app out. We got the skin colors in January, the toy safety in February, the CE certification. We're just about to put the lion mark on it, which is another toy thing that consumers want to see. And we put an app out in March, and it was kind of new and noteworthy by Apple. So we've had like 140,000 users in the past month, and dolls are now going to places like Bangladesh and Kuwait and all sorts of really interesting places. The app just sells dolls, but the next step is to turn it into the game, which we've been promising for ages, which is where this big loop finally closes, where your digital character can be turned into a physical object but we will be able to create and sell, and maybe people can sell to each other, both digital and physical goods. Using laser printing, for instance, we can have users create patterns for the clothes and then print it onto real cloth and turn it into real clothes for your real doll that you've designed in an app. Click. And then going forwards for us, a doll is just a robot, is just a vehicle. It's just a 3D mesh around engineering. I found out in this process that pediophobia is the fear of dolls. It's quite popular, especially in men. But it's something to do with the eyes. But these two little guys here are exactly the same software manufacturing platform. And we'll give you a hint of what our second product is. If you want to have a go, it is as easy as picking up your computer or your tablet. This is one example. This is 123 Sculpt, which is a free app by Autodesk, who also make the high-end 3D software like 3D Studio Max, which we use. You can just download that and fiddle around. They'll start you off with a head or an animal. And some people get really good at it. So this was created with 123D Sculpt. And then you upload it to Shapeways. It's that simple. It will price it for you. It will check the model for you. You just hit buy, and your object will come to you. It's really cool. Have a go.
Thank you.
I wish I could remember what my number 5 was.
We'll find it again.
Yeah, exactly, as soon as I go off stage.
So a lot of the startups we usually see, especially in the software space, they go for these really, really sexy challenges, and it's all very slick and streamlined. You're building these incredibly cool dolls and toys.
Yeah, the
Yet
open alpha.
the challenges you face are incredibly, almost completely uncool. It's like dirt, it's licensing, it's shelf heights.
Yeah.
What are you doing wrong? I mean, what's the deal?
Well, that's real life, right? This is a real product. So there are some things that the internet can't solve yet, like the physicality of us making this and then shipping it to you in Bangladesh, right? I mean, the sci-fi of this, which is only sci-fi now and will come together as soon as everybody has home 3D printers, but that's not next year, will be that you will print your own, so that will solve the shipping problem. But right now we still have shipping, we still have safety certification, we still have all of that kind of stuff. So hardware is hard, as you said yourself.
And safety certifications is obviously a very, very big deal. And I imagine they're not really equipped to license anything that looks very different every single time you produce it, right? How does it work?
At all. So so we said they said, so what do you mean every doll is different? And we said, everyone is different. They said, well, you have to test every single one of them. And we said, no, no, let's try and work this out. So what we did was we printed all of the extremes. So you'll see there's elf ears on this one, and they're kind of pointy. So we printed the ugliest one we could make, basically, and the pointiest one. This is a normal hand, but you can get a pointy hand and a V hand and all sorts of stuff. So we printed all of that. So we had 4, and the 4 skin shades, and sent those off. And they said, right, because of these are all the extremes, everything in the middle is OK. Right. So that's how we did it in Europe now. So we're European certified, EN71. Apparently, when we go to America, there is a different system, and then there's another system in Asia again, but it's just a case of doing it one by one. Okay. At the moment, they are just labeled as CE certified. And if you sell direct to consumers, if they're buying from a European website, it's understood that they understand they're buying a European product.
And if you can answer that without going too deep into your internal research, I imagine most people don't go out and say, today I want to buy a 3D printed toy. Probably most consumers aren't really aware of the process.
Right. Well, to be honest, we don't. I mean, we sort of talk about it. I talk about it in places like this. But I think we mention it on the site and in the app, but only briefly. Because obviously, some people are interested in 3D printing, but most people are just interested in the end product. So we have the same age-old problems as anybody has had of how do we get this in the hands of kids and how do we get them to see it without having that deal with Toys R Us, etc. When Lego launched Lego Friends, which is pink and for girls and would have sold itself, they spent $60 million marketing it. So we're up against those usual challenges. But to be honest, I think the fact that they're slightly weird looking and you get to make your own, it's spreading.
OK. Then last question. Can you tell yet when you're actually going to launch the game?
The game, if I say it, my dev team will kill me,
Then
so I'm going to say it, July.
Fair enough. We don't want to get you killed. Thank you so much.
No worries, I've left the clicker. Thanks, everyone.